Okay, let's see an example for AVL tree. Now these are the elements we are going to insert into the AVL tree. So the first element we are going to insert is 14. The next element is 17. So 17 is greater than 14, so it will be inserted to the right subtree. The next element is 11. So 11 is less than 14, so it is inserted to the left subtree. So as you insert, you have to start calculating the balance factor. So what is balance? Height of the left subtree minus height of the right subtree. So now when you consider this node, there is no left and there is no right. So the balance will be 0. Now when you consider this one, the height of left minus right. So what is the height of left? The height of left is 1 and here the height of left is 1. So 1 minus 1 will be 0. And here there is no children, so this also will be 0. So you have to calculate the balance factor after every insert, and the balance should be 1 minus 1 and it should be 0. Okay, so if the balance is not achieved, then you have to do the rotations. Okay, now let's insert the next element. The next element is 7. 7 is less than 11. Okay, so it has to be inserted to the left subtree. So I will insert 7 here. Okay, so now after every insert you have to calculate the balance factor. So let me calculate the balance factor again. Okay, so now what is the balance factor of 7? No left, no right, so balance will be 0. What will be the balance factor of this node? The height of the left is 1 and right is 0, so 1 minus 0 will be 1, and this one will be height of the left subtree is 1 2 2 minus 1, it will be 1 again, and this will be 0. Okay, so again it is a balanced tree. Now the next number that we have to insert is 53. Okay, 53 is greater, sorry, here you have 14. Okay, so 53 is greater, so you have to insert in the right subtree. Okay, so now again you have to calculate the balance. Okay, so again we have to calculate the balance factor. Let me calculate the balance factor again. Now here the balance factor will be 1 minus 0, 1, here it will be 0, here it will be 2 minus 2, again it will be 0, here it will be 0, here it will be minus 1. Okay, 0 minus 1. Okay, so these are the balance factor. Now the next element we are going to insert is 4. 4 is less, so we will insert into the left subtree. So we will insert here. Now you have to calculate the balance factor again. Okay, so let me calculate the balance factor again. So here the balance factor will be 0. Here the balance factor will be 1 minus 0, so that will be 1. Here the balance factor will be the height, this one. Okay, the height is 2, 2 minus 0, so this will be 2. So here you saw the balance is not 1 minus 1 and 0, so it means it is not a balanced tree. Okay, so you have to do the rotation. Okay, now this is the first node which is affected by its balance factor. So here you have to do the rotation. Now there are 4 cases for rotation. One is LL cases, second one RR cases, third one LR case, fourth one RL case. Okay, for these two you need only 1 rotation. For this one you need 2 rotations. Okay, now this is the node we have to rotate. So let me draw this node separately. Okay, 4, 7 and 11. Now you can see all are in the left side. Okay, left, left. So the tree is heavy on the left side. So if the tree is heavy on the left side, you have to do a right rotation. So just have to do a right rotation. Only 1 rotation you have to do, and you have to do the right rotation. So just you have to bring 11 down. So finally it will become like this. Okay, so I'm going to replace this node with this node. Okay, So now let me replace this node with this node. Okay, so just I'm going to draw this node. So now it becomes like this: 7, 4 and 11. Now calculate the balance factor. The balance factor of 4 will be 0, here 0, here 1 minus 1 will be 0, here 2 minus 2 will be 0, here the balance factor will be 0, here the balance factor will be 0 minus 1, so it will be minus 1. Okay, so it's a balanced tree. Okay, so the last element that we inserted is, I think we inserted 4. The next element we want to insert is 13. 13 is less than 14. Okay, 13 is less than 14 and greater than 7 and greater than 11. So it will be inserted to the right of 11. Now again calculate the balance factor. So let me again calculate the balance factor. Okay, now what is the balance factor for this node? Balance factor for this node is 0. Balance factor of 11 will be 0 minus 1, so this will be minus 1. Balance factor of 7 will be 1 minus 2, so this will be minus 1. The balance factor of this will be 2 minus, actually the height of 14 will be, you have to take there are two paths here. So this is one path and this is another path. So you have to take the longest path. So what will be the height? The height will be 1, 2, 3. 3 minus 2, so this will be 1. Okay, the balance factor 1. Here the balance factor will be 0 minus 1, so this will be minus 1 and this will be 0. So you should be very careful when calculating the balance factor. Okay, so again the tree is balanced. The next element we have to insert is 12. So 12 will be inserted again to the left. 12 is greater than 11 to the right side but less than 13. So 12 will be inserted here. Okay, so now we have to calculate the balance factor again. Okay, so let me calculate the balance factor again. Okay, now let's calculate the balance factor. So this will be 0. This will be 1 minus 0. So this will be 1. Here the balance factor, here you see the left subtree is 0 and the right subtree is 2. So 0 minus 2, so this becomes minus 2. So this is the first node which is not balanced, right? So it means you have to rotate this one. Okay, it means you have to rotate this one. Now what is the case here? This is your right subtree, this is your right child and this is your left child. So the case here is RL case. So here you can see in RL cases you need 2 rotations. Okay, so what are the rotations you need is, first you should bring all this in same direction. See, one you have right, other one you have left. So if you have a case like this, you have to bring this to the same direction. So if you want to bring this to the same direction, here you have to do a right rotation first, right? So you want to bring everything to the right side. So first you have to make a right rotation. Okay, you have to bring this node this side. So when you make this one, don't forget you have to change the locations. So 12 will go up and 13 will come down. So the first rotation will be your right rotation. So the node will become like this: 11, okay, 13, sorry, 12. 12 will go up and 13 will come down. So all will come in the same direction. So you should be very careful that the change in the nodes should be there. Okay, when you rotate, right rotate, 12 will go up and 13 will come down and all are in the right direction. Now the tree is right heavy. So if it is right heavy, you have to do a left rotate. So if it is a left heavy, you have to do a right rotate. If it is a right heavy, you have to do a left rotate. So now move left side. So when you move left side, the tree finally becomes like this. Okay, the tree finally becomes like this. So now I'm going to delete this part and I'm going to replace it with this one. So I'm just going to delete this part of my tree. Okay, and I'm going to replace it with this one: 12, 11 and 13. Okay, now let me calculate the balance factor of the tree. So here it will be 0, here it will be 0, here it will be 0, and here it will be 1 minus 2, so it will be minus 1, and the height of 14 will be 1, 2, 3, the maximum. You have to take the maximum height. So 1, 2, 3, 3 minus 2, so that will be 1. This will be 0 minus 1, so this will be minus 1, and this will be 0. So the tree is a balanced tree. Okay, the next element that you have to insert is 8. 8 is less than 14, and 8 is greater than 12, but less than greater than 7, but less than 12, and less than 11. So 8 will be inserted here. Okay, now again you have to calculate the balance factor. So let's update the balance factor. Okay, so I'm going to calculate the balance factor of this tree. So here the balance factor will be 0, and this one will be 1, this one will be 2 minus 1, 1, and the balance factor of 7 will be 1 minus 1, 2, 3. So 1 minus 3 will be minus 2. Okay, it will be minus 2. So this is the first node which is affected, right? So you have to take the 3 nodes. Okay, you have to take these 3 nodes. Why you have to take these 3 nodes? Because here only you inserted, right? In left only you inserted. So you have to take this 3 left. Okay, so this is the first node which had imbalance, minus 2 factor. So you have to take the 3 nodes in this direction. Why? Because you inserted 8 in the left side. Now this is you have to do the rotation. Now what rotation you have to do here? This is right, this is left. Okay, so you have to do 2 rotations. Okay, so let me write this node separately. 7, 12 and 11. Okay, so this is right and this is left. So now the first rotation that you have to do is, first you have to do a rotation so that all comes in same direction. So you have to do a right rotation so that all comes to the same direction. Okay, so remember, always you should change the location of the node. So now it becomes like this: 7, 11 and 12. So all are in the right side. Now the tree is heavy in the right side, so do a left rotate now. So when you do a left rotate, 7 will come down. Okay, so I'm going to replace these 3 nodes with this node. Okay, so let me redraw my tree. So 11, so this node I'm going to replace, so it will replace with 11, 7, 12. Okay, so after I replace this, now I am going to attach the parents. The left of 7 is 4, so left of 7 is 4. Then left of 11 is 8. See, left of 11 is already occupied by 7. So I am going to attach to left only, but right of 7. Left of 7 is already occupied. See, left of 11 is 8. So left of 11 is already occupied. Okay, so I am going to attach to the left side only, but to the right of 7. Okay, then right of 12 is 13. So right of 12 is 13. So this is my final tree now. Okay, so this is how I have to do the rotation. Now my tree is a balanced tree. Okay, now let me calculate the so if you calculate the balance, it will be balanced definitely. Now let's go to the next one is 60. So 60 greater, greater and greater. So you have to insert 60 here. Now calculate the balance. This will be 0. This will be 0 minus 1. So this will be 0 minus 2. So this is the first node which is affected. So these 3 nodes I need to rotate. So here you can see what case is this one, right, right. Okay, so if your tree is heavy on the right side, then you have to do a left rotate. So let me draw the node separately here. Okay, so you have to do a left rotate. So finally your tree will be like this. I'll just bring 17 down. Okay, now these 3 nodes will be replaced with this one. So just I will replace these 3 nodes with this node. Okay. Now again the next element I want to insert is 19. So 19 is I think here it is this is 14, right? Sorry. Okay, so the next element we have to insert is 19. 19 is greater than 14, less than 53, greater than 17. So we have to insert here 19. Now calculate the balance. 0, 0, this will be 0, this will be 2 minus 2, so this also will be 0. Here you have 3, 3 minus 1, 2, 3, so this also will be 0. This one will be minus 1, this one will be minus 1, this one will be 2 minus 1 will be 1. So you can see the tree is balanced tree. The next element you have to insert is 16. So 16 will be to the left of 17. Okay, so here you will insert 16. Again I think the tree will be balanced tree. The next one you have to insert is 20. So 20 will be inserted to the 20 greater than 14, less than 53, greater than 17 and greater than 19. So 20 will be inserted here. Now let's calculate the balance. Okay, let me calculate the balance factor. Okay, okay, now this will be 0, 0, this will be 0, 0 minus 1 will be 1, this will be 1 minus 2 will be minus 1. Okay, this will be, the height of this one will be 2, sorry, the height of 53 will be 1, 2, 3, 3 minus 1, so this will be minus 2, sorry, plus 2. Okay, 3 minus 1 will be 2. So here this is the first node which is affected. So you have to select the 3 nodes in this direction because you inserted 20 here. So you have to select these 3 nodes and you have to do the rotation. So what are the cases here? This is left and then right. So let me write this node separately. 53, okay, 17 and 19. So you have to do the rotation. Now what you have to do, so this is your left, this is your right. So now you have to do a left rotate so that it comes to the same direction. So whenever you do this, you have to make sure you exchange the node position. So it will become like this: 53, 19 will come up, 17 will go down. Okay, and all are in the same direction, left direction. So the tree is left heavy, so you have to do a right rotate. So you will get like this: 19, 17 and then 53. So now I'm going to replace these 3 nodes with this node. Okay, so let me draw the tree here. So let me draw it here. So 14, okay, 11. So I'm going to replace this with 19, 17 and 53. Now attach the children's. To the left of 53 you have 60. Okay, left of right of 19 you have 20. So there is no place here. So to the right only I am going to attach my 20, but to the left of 53. Okay, still it is in the right side, but to the left of 53. then left of 17 will be 16. Okay, then the other remains unchanged. And 4. Okay, so this is your final tree. So hope you understood how to do AVL insertion. Thank you for listening.